Hello everybody, this is Miss Pie. I am giving you directions in this video on how to do the vector project and I will give you some helpful hints and some reminders. So a couple things. Number one, there is a typo on the project page, the instruction page. If you look right here where it's highlighted in yellow, the reason why I highlighted it is because on your paper it says inches. It should say centimeters. And that's not a huge difference. The biggest thing is I want you to do all your measurements in centimeters and not inches. It'll be easier to do centimeters, especially when you have to do portions like half a centimeter or 3/4 of a centimeter or whatever. All right, so biggest thing, I want you doing all your measurements in centimeters. Okay, let's go ahead and go through this. So basically you have a ship, you start at your home port. Let me pull up the map real quick. Here's our map. You're starting at your home port. You're going to sail your ship, sail, not S-A-L-E, but S-A-I-L, sail the ship from island to island, and there are 5 different islands you have to go to. And one of the islands, Port C, has gold added. And one of the big things to remember is once you get to Port C and you get the gold, the pirates that are going to be hanging out wherever the X is on your map, that is, X marks the spot. That's where the pirate ship is going to be. I hope you guys like my little origami pirate ships. Anyway, so as soon as you leave Port C, the pirates are going to follow you. Okay, so if you look here, after I leave Port C, I can go over to Port D, or I can come down here to Port B. I just need to kind of figure out which is the better port to go to. And then the pirates are also going to, whichever port I go to, that's where the pirates are going to go to. So if you look here, it might be faster for the pirates to get to this port, so it might be better for me to go to Port B. That you guys will have to figure out on your own. And if you look around and compare your map to my map to the other group's maps in your group, you will find that everybody has a slightly different map, so you cannot just copy another group's map. All right, so you guys probably have noticed all these sticky notes. And what I did is, just to make my video shorter, I went ahead and measured all these lines. And please feel free to sketch these lines on your map. That's why every group has its own. And so just get your ruler, sketch the lines. Notice that these are not just straight perpendicular lines. I don't have a 90-degree angle over and over again. We've got lots of different angles. So ships do not sail just on a 90-degree grid. And I think I left a note somewhere in the instructions on this packet that if you only have 90-degree angles, I am going to not give you credit for doing the test or doing this project. Okay. One year, somebody realized that 90-degree angles make it super easy to do to define your X and Y components. You don't even have to calculate anything. And he thought he was being smart, and I was like, no, you're not. You're going to redo it. That kid was not very happy with me. But I'm sure none of you guys will try to do that thing. Anyway, so go ahead and draw the lines, and you guys might decide to draw the lines first or draw the lines as you go. I do know the more you sail around, the busier your map gets, so it might be easier to draw the lines that will take you from one port to the next port, do all the measurements for those and do all the calculations for those lines, and then move on to the next group of lines. Okay. So one of the things that you're going to do on your measuring is use your meter sticks, measure centimeters, and then you also want to get your bearings. Now, to get your bearings, hopefully there's somebody in your group that has a compass app on your phone, and you're going to just download that. If you don't have a compass app, just download it. It's pretty easy. And the way this works is you set this big line here and you put it on the direction that you want to go. So here's my line, and so I just lined this line up with my line, and it actually tells me in the center what my navigational bearing is. Okay, so in this case, my bearing was 79 degrees, and then so that's how you're going to use your map. Okay, is you measure the lines and you get the navigational bearings. Okay, feel free to write them down on your paper. Another thing you need to be aware of is as you sail from, or when you leave your home port, the speed of your ship is 40 nautical miles an hour, but you also have an ocean current that always is moving south. So your direction is negative 90 degrees. Your bearings, I think, are 180. Anyway, it's going south at 10 nautical miles an hour. Okay, and then every time you go to a different port to pick up trade goods, your ship is going to slow down just slightly. So when you go to port A, you're picking up sugar, it's going to slow down the ship 2 nautical miles an hour. Cotton will slow your ship down 1.5. Gold is 5 nautical miles an hour. Rum is 3.75. Tea is 2.25. Okay, and then the last thing is the pirate ship. Its speed is 75. Man, that would be crazy. Its speed is 45 nautical miles an hour. So even with your ship being empty, the pirate ship will have a faster speed. And the reason why is because the pirates want to be faster so they can capture you, or so they can outrun you if it's like some ships that have guns and soldiers and all that fun stuff. All right. So part of the project is you have to keep your ship's travel log. And every time you change directions, you have to fill in the navigational bearings, rotation angle, speed, and the distance you traveled. And then there is a column so that you can add or write down what port you get to. So when you get to a port, go ahead and put that in the column. I'll show you some examples. And then in the packet, there's a whole bunch of vector tables already set up for you. You will use those to do your calculations. Yeah, here's the warning about do not do just 90-degree turns. Let me see. All right, so let's go ahead and look at some examples. So back to our pictures. So when we leave our home port, if you look, sorry, it's upside down. I might be able to flip it around, but I really don't need to. So from my map, I got the bearing of 79 degrees and the centimeter, and it was the path that I was going to go on before I changed directions was 13.5 centimeters. Okay, and so I'm just writing my bearings in the 13.5, and you know, I had a student do all this for me. She measured several different lines for me. And notice on my ship's log, you don't have this on your ship's log, but you can use your margin. I actually labeled each line just to keep me straight, just 1, 2, 3, 4. On my map, notice the 1 in this box, a 2 in this box, and then a 3 and a 4 and so on. Okay, so on your map, if you would like to, you can go ahead and label those lines, and you can write your bearings and your centimeters right on your map. It might come in handy later on, especially if you don't get everything finished today. It'll make it easier to get your map in the basically same place tomorrow on Wednesday when you come in, so that you have the same kind of navigational bearings. All right. So for the ship's log, you get your navigational bearings, but we know that our vector formulas, we have to convert from bearings into degrees. And so to do that, it's just 90 minus 79 degrees will give us our rotation angle of 11 degrees. But then we need to we need to calculate the angle that we want to steer the ship so that it will follow the path that we want it to go on. Okay. And then to do that, we're going to go down there it is. We're going to come down here and we're going to do the calculations. So we have to do the vector components because the ship its initial magnitude or speed is 40 nautical miles an hour. We want it to go on a direction of 11 degrees. And then we need to go ahead and calculate the components for that and just use your calculator. Hopefully you remember, make sure you're in degree mode up here. For your x component, it's 40, your magnitude times cosine of your angle, which is 11 degrees. Push enter and you get 39 degrees. That's your x value. Or your x component is 39.26, whatever. Okay, and then for your y value, same thing, you're just changing it to sine, and you get 7.63 for your y value. Now, you also have the ocean current that you have to deal with. Its magnitude is always going to be 10, and its direction is always going to be negative 90 degrees. And so then the components will always be 0 and negative 10. Okay, so this is my components for my ship, and then this is for my current, ocean current. And notice every single time I do this, let me see, yeah, every single time my current's going to be exactly the same. Okay, if you want, have somebody in the group just go through and put that down on all of them. For the ocean current, this is what you're going to have the whole time. All right, now, if you remember, hopefully you remember, on Friday we talked about how if we want to go a certain path and we have some sort of force that is pushing us off path, then we need to figure out which way we want to steer. We're going to subtract whatever the force is. So to find the direction we want to steer our ship, we have to subtract our components. But then to calculate the speed or the magnitude, we're going to add the components. So when we do that, when we're subtracting the effects of the current, we're looking for the direction, and we get this. When we're adding the effects of the current, we are looking for our speed. Okay, so if you look here, notice that, excuse me, let me go back. Because your x component on the current is 0, you really don't have to do anything to the x component. That's always going to be the same as what you have up here. But for the y component, you take your y value and you're going to subtract negative 10. And so that's how we get a positive 17 here. And that's for the direction. That's what we're going to use for the direction. And then we add the negative 10 to get our speed. All right. So then to find our direction, we need to take our y value, y component here. So it's going to be inverse tangent, the y component divided by the x component. Notice I did not just type in 17.6 here. What I did is when I was here, I scrolled up, I highlighted it, I pushed enter, and the calculator just popped it right into my fraction. This one. And then I put the division line, and then I came up here, scrolled up to this one, push enter, and it will pop the whole thing down here. And what this does is it just gives me a more accurate answer. Okay, so the direction that I want to go is 21.2 degrees. And so on my table, I'm going to put the 24.2 degrees here. And then to calculate my magnitude, I'm going to do the Pythagorean theorem, square root of your x component squared times your y component squared. And this time we're not using this 17.6, we're using the negative 2.3. If you have a negative number that you're squaring, make sure you put it in parentheses before you do the square, and make sure you have this squared on the outside of the parentheses. All right, so when we square all that, we get 39.3 nautical miles an hour. And so with the effects of the current, it's actually slowing us down almost a mile an hour. Okay, so it'll be very interesting to see how the current affects your speed. All right, so now that we have this, we have our direction, we have our magnitude. We want to go ahead and take those and put them in our ship's log. And so our magnitude is representing our speed, so that's why we put the 39.3, and that should be, if you want to do the whole nautical miles per hour, that's fine, but you really don't have to since I already have it up here. I'm not going to count off points if you leave it off. I'm not going to give you extra points if you put it on there. But then the measurement on our angle or our direction that we wanted to steer the ship is going to be 24.2 degrees. Notice it's almost double the angle here. Okay, and this is the direction we want to steer our ship so that it will go, it'll stay on the path that we want it to stay on. Okay, and then we always need to convert back from our rotation angle back into our bearings, because compasses have bearings, not rotation angles. So then 90 minus the 24.2 is going to give us 65.8. Okay, so really for this column here, this is just you're using your compass coordinates on your phone and you're using your map to fill in this column here. The distances, you're just measuring them from the lines that you're drawing on your map here. And then you always want to, whatever your rotation, whatever your bearings are, do 90 minus those bearings to fill in this column here. And notice it's okay to have, whoops, let me scroll up. It's okay to have a negative rotation angle. It's fine. You can leave it as a negative or you convert it to a positive. It's totally up to you. I don't care one way or the other. I'm pretty lazy, so I only want to do one calculation, and so I'll just leave it as a negative. Okay. I am not going to do all of these calculations. Don't worry about it, but there is a couple other things I wanted to show you. So let's look at the next, let's look at line 4. So on our pictures, let me see, where's our pictures? So we leave our home port, that's part 1. We turn and go this direction, that's part 2, and we're going that direction for a long time. And then we turn here, that's part 3, and then part 4 is just right here. Now notice, yes, this is a map and these islands are all flat, but notice I'm not just taking my ship to some spot on the island. Like, it would be much faster to just go right here. You can't do that, because what happens with islands is just because you have land there doesn't mean necessarily that you can actually land in that spot. A lot of times you'll have one side of the island will have cliffs, it'll have like no shore whatsoever, there won't be any boat docks whatsoever, and they won't have any safe place to land on the islands. So you cannot just go to just any random spot on the island. You have to actually go to the port that I've marked on the island with the X. And you'll notice most of these ports are kind of in a protected cove on the island. And those are just kind of like circular spots that are kind of sheltered from some of the heavy waves of from the ocean, is where they typically will put the ports, and they'll build up towns there. All right, so back to the part 4. So on part 4, I'm going up, I'm going to land on my port, and so if you see here, I put a C down here. I left these blank because I was still in the middle of selling the ship, and so I finally landed in port C, so I put a C here. And then, so let's go ahead and calculate this, the information for this segment of our trip. So our direction was negative 256 degrees. So I am over here. Oh, sorry. One other thing, notice I put a 1 in this little empty box here. I don't need to put anything there, but again, just to keep myself on track of where my calculations are for which line on my ship's log, I put a 1 there and I put a 4 there because that was the 4th one. All right, so now the direction I'm putting down is a negative 256 degrees. Notice my speed of my ship I'm still starting with 40 degrees. Even though up here I calculated that with the current I was only going 39.3 degrees. Each time you do the calculation, you always want to start with the speed of the ship without the effect of the ocean's current, because at this point, we're adding the ocean's current on there, okay? So I have the speed of the ship is going 40 miles an hour, and the direction is negative 256 degrees. And I come over here back to my calculator, and I'm doing 40 times cosine of negative 256 and 40 times sine of negative 256, and I get my x and my y components, okay? Notice my x component is negative here. My y component is positive 38.8. And then for my direction, I'm going to subtract the ocean current. And for the speed, I'm going to add it. I'm going to do inverse tangent. And I do my calculations. And on this one, when I do inverse tangent, I get negative 78.7 degrees, or 0.8 degrees, I guess, if I was rounding correctly. But don't forget, if you have a negative x value, you need to add 180 degrees to that angle. And so my actual angle is 101.2 degrees. And then when I calculate the speed, I'm using this y component, not this one. And my speed is going to end up being 30 nautical miles an hour. Okay, so it looks like, let me see, here's my components. I'm going to add for the speed and subtract for the ocean, or for the direction, and I put my new rotation angle and my new magnitude. So notice right here, I'm pretty much fighting that current a lot. It is really slowing my ship down. And on the ship's log, way up here, I'm going to fill in my speed as my magnitude and my direction in rotation angles. And then I need to calculate my bearings. And for this, when I calculate my bearings, I'm going to do 90 minus my rotation angle, and it gives me negative 11, a bearing of negative 11 degrees. Now, if you remember, I've said it's fine if we have negative rotation angles, that's okay, but we should never have negative bearings. So if you get a negative angle for your bearings, you need to add 360 to it, and that new calculation will be what you record on your ship's log. So don't give me a negative bearing. I will take points off if you write down a negative bearings there. Okay. All right. We're almost done with the video. Last couple things I wanted to talk about is, now that I've gotten to port C, once I leave port C, my ship is going to slow down my initial speed, because in port C, I'm going to grab some gold, and the gold slows the ship down by 5 nautical miles an hour. That information is up here, okay? So when I am doing my calculations for when I'm going to for part 5, my rotation angle is negative 149. So here's my rotation angle of 149, and normally I would put 40, but because I have the gold on my ship now, instead of 40, I'm going to subtract the effect of the gold on my speed. So now my magnitude is 35 nautical miles an hour. And then I'll do all the calculations like I normally have been doing. Okay. A couple of things. When you are calculating your the pirates' information, please put their information in this space that I provided on, I think it's like the 3rd page of the project. Hold on, it's fourth page of the project. Okay, just so I know where the information is for your pirates. Okay, and then you need to do the distance, bearings, angle, and go ahead and use one of these table things to do their calculations for their speed and actual direction. Okay, and then when you go to figure out who got to the next port first, you're going to calculate the time, you have to take your distance and divide it by your speed. Okay, and notice a lot of times it'll take you more than one line to do that. So here I would have this this distance divided by the, hold on, we said distance divided by speed. Yep. Yeah. So to calculate my time, I will have 13.5 nautical miles divided by 39.3 is my speed. And then I'm also going to have to calculate whatever the speed is for the next line, or the distance from the next line divided by the speed for that line, and then plus this distance divided by this speed. Okay, so you can't just average them, just take it each part and multiply it all together. There's really no space that I've provided to show your work on this. If you want to just show that information, where? I don't know, you in your margins on the cover sheet, I think, or if you have some extra space. Let me see, did I give you 2 pages of ship's log? Yeah, just show the work on the bottom of your paper or something, okay? All right, so you need to calculate your ship's time and the pirate's time, and whichever number is lower, their time is faster, okay? So you want to outrun the pirates. So either you have to have a smaller number on the time, or you have to be within 15 minutes of each other. And I'm going to let you guys figure out how to convert decimals into minutes. So any of your whole numbers will be hours, and I'm willing to bet there's at least one person in the classroom that knows how to convert your decimals into minutes. All right, so that's pretty much it. The last thing I want to remind you of, let me see. I think it had to do with our map and our directions. So let me pull up this. So one thing I noticed is that when you're doing the calculations here, there's going to be a lot of times where you get to a port and then you're going to leave the port on the exact same path. Okay, so like with this one, I might go this way and then I'll go off this direction somehow. Okay, so it should work out that if I'm going towards the island, my bearings would be 292 degrees for this port here. And then if I'm leaving the island, it should just be 180 degrees opposite of that. Because if I'm going this direction, then I turn this direction, I'm just changing it 180 degrees, right? So I should just be able to subtract 180 degrees from this. And if I do that, my bearings would be 112 degrees. Okay, what I notice is that that's what it should be, but if I actually measure it with my phone and I change my phone around, when I turn my phone around, I got a bearing of 138 degrees. Or yes, 138 degrees. And so, it's not too far off of 112 degrees, but it's definitely not 112 degrees. So that is one thing I want you guys to keep an eye on. Couple reasons why it might do this is when I was doing the measurements, if I shifted the paper a little bit after I measured my 292 degrees here, and then if I shifted the paper, it does change the direction. Okay, so be very careful with doing your measurements and shifting your paper around. And then don't just take it for granted that going the opposite direction will be 180 degrees difference. So that's something to keep an eye on. See if you can figure out why my calculator or why my phone compass was doing that. It might be interesting to find out. All right, I think I've pretty much covered everything. I've given you warnings. Please feel free to draw on your map, label everything as much as you can. I know some years I had students that had drawn like whales on the ocean and an octopus and squid and fish. Just have fun with this project. It's a really neat project. Have fun with it. And I will see you guys on Thursday.